Good morning dear students, this is Bonani Porokasto. I welcome you all to today's video. Here we are doing the chapter Continuity and Differentiability. Question number 1 of exercise 5.3. Here we have to find dy by dx of this equation. So here the equation given is 2x plus 3y is equal to sin x. So to find dy by dx, we will differentiate both sides with respect to x. So for that we have to write d dx of 2x plus 3y and d dx of sin x. d dx of 2x means here we can use the formula of uv. So whenever 2 is constant, d dx of x is 1, and whenever we will keep x as constant, d dx of 2 will be 0. So here we have written only 2. Now d dx of 3y, here also we can use the formula of uv. Whenever 3 is constant, the derivative of y with respect to x, for that we have to write dy by dx. Plus whenever we will keep y as constant, d dx of 3 will be 0. So this part will become 0. So we have not written this part. So from here we will get 2 plus 3 dy by dx is equal to cos x, because d dx of sin x is cos x. Now from here we can find dy by dx. Question number 4, the equation given is xy plus y square is equal to 10x plus y. Here also we have to differentiate both the sides with respect to x. So for that we have to write d dx of xy plus y square and d dx of 10x plus y. Now to differentiate this d dx of xy, we can use the formula of uv. Whenever x is constant, dy by dx. Whenever y is constant, d dx of x. So from this part, d dx of x will become 1. And d dx of y square means we have to use the formula of x to the power n, which means n x to the power n minus 1. d dx of x to the power n is equal to n x to the power n minus 1. So if we use the formula here, it will become 2y. And since we are differentiating y with respect to x, we have to keep dy by dx here. Now d dx of 10x is sec square x and d dx of y. We will take this dy by dx to this side and this y to right hand side. From here now we can take common dy by dx. After taking common, we can find dy by dx. So here the important point is, look at this, whenever we are differentiating y with respect to x, we have to use the formula first, then we have to keep dy by dx, because since d dx of x square is 2x, because here we are differentiating x with respect to x, but in our question we are differentiating y with respect to x. So for that we have to keep 1 dy by dx. Whenever we will differentiate y with respect to x, then we have to keep dy by dx. This is question number 4. Question number 7, the equation given is sin square y plus cos xy is equal to k. So here k is constant. We have to differentiate this equation with respect to x. So for that we have to take d dx on both the sides. So if we write d dx of k, then it will become 0 because k is a constant. Now we will differentiate sin square y with respect to x and cos xy with respect to x. So for that d dx of sin square y, we have to first use the formula of x to the power n, d dx of x to the power n. If we use this formula, it will become 2 sin y. Now we have to again differentiate sin y. Now for this one, we have to first use the formula of d dx of cos x. So it will become minus sine xy. Now we have to differentiate xy again. Now from d dx of sine y, we can use the formula of d dx of sine x. d dx of sine x means cos x, but here in place of x we have y. So we will write cos y. Since here we are differentiating a function of y with respect to x, we have to keep dy by dx. For the next one, we can use the formula of uv. So here we will keep x constant and dy by dx plus y constant d dx of x. So now from d dx of x we will get 1. So it will become x into dy by dx plus y. From here we can find dy by dx by taking common dy by dx from these two terms. In this way we can find dy by dx. Question number 8. Here the equation given is sin square x plus cos square y is equal to 1. So here sin square x is a function of x, but cos square y is a function of y. To find dy by dx, we have to differentiate both the sides with respect to x. So here we have written d dx of sin square x plus cos square y equal to d dx of 1. So from d dx of 1 we will get 0 because 1 is a constant. Now we will differentiate sin square x with respect to x and cos square y with respect to x. So to differentiate sin square x with respect to x, first of all we will write 2 sin x because here we are using the formula of d dx of x to the power n. So it is n x to the power n minus 1. So here we have used this formula, so it will become 2 sin x. Now we have to again differentiate sin x because here only we have done the work of this square. Now we have to do the work of this sin x. And for cos square y, first of all we have to use the formula of d dx of x to the power n. So for that it will become 2 cos y, and then we have to again differentiate cos y with respect to x. Now d dx of sin x means cos x, and d dx of cos y means minus sin y, and since we are differentiating a function of y with respect to x, so we have to write this dy by dx. Here we have used the formula of sin 2x, and from here we can find dy by dx. So dy by dx is equal to sin 2x by 2 sin y cos y. 2 sin y cos y means sin 2y. So our answer is sin 2x by sin 2y.